Hello, today we are going to be taking a look at how to find the volume of a cone. So our last one was a cylinder, and this is going to be very similar to that because it has one end that does look like a cylinder, but then it comes to that point. So cones are similar to pyramids and to cylinders. It's kind of a mixture of the two. So instead of having a polygon or a flat-edged figure, for example, a triangle or a hexagon as a base, you have a circle. This also causes you to have a curved lateral surface instead of a triangular lateral surface, lateral faces. Similar to finding the volume of a pyramid, we can find the volume of a cylinder using this formula right here. Now, what do you notice is different about this formula as opposed to the one that we used for the cylinder yesterday? So if you remember, the one that we used for the cylinder was the volume was simply equal to that base area, which was the area of a circle because it was a cylinder, times the height of a figure. So finding the volume of a cylinder was just like finding the volume of any prism that we have, whether it be a triangular or a rectangular prism. We find the area of that base shape, and then we multiply it times the height. And with our cone, because it's just like a cylinder, it's going to be a third of that. So there's going to be a specific formula that we are going to use for that, and it's going to be a whole lot like our cylinder one that we came up with, because we know to find the area of our base, we're going to do pi times r squared, because that gives us the area of a circle. So when I come down to here, I'm going to take this formula, and instead of that b, I'm going to substitute in pi times r squared times the height. We're going to use that formula then to find the volume of the different cones. So down here we have 3, and we're going to put them in order from least to greatest. And this one again, whenever you have a question that says find something in terms of pi, and it doesn't tell you to use 3.14 or 22/7, they want you to use the symbol, and then they don't want you to substitute in for it. So for instance, if I take a look at our first cone here, the height is going to be 3, and then the radius of my circle is also 3 there. So we'll call this number 1. So the volume of cone number 1 is going to be 1/3 times pi times the radius squared times the height. It's a lot of letters, or lots of 3's in there, isn't it? So then I've got 1/3 times pi times 9 times 3. 1/3 times pi times 27. Now multiplying by 1/3 is the same thing as dividing by 3. So that's another way you could also write this. I'm going to go ahead and I'm going to reorder these. So I'm going to have 1/3 times 27 times pi. Well, 1/3 of 27 is 27 divided by 3, which is 9. So I get 9 pi, and this is still a volume, so that's going to be centimeters cubed. So that is the volume of this first cone here. My second cone is much taller, but its radius is smaller. So for cone number 2, I'm going to have 1/3 times pi times 1.5 squared times 10. So 1/3 times pi and 1.5 squared is 2.25. So times 10. When I multiply something times 10, remember it just moves the decimal point over one place, makes it 10 times bigger. So 22.5. And I'm going to go ahead and put my pi here, and I'm multiplying by 1/3, which means I am dividing by 3, which gives me 7.5 pi, and that is still centimeters cubed. So this one's a little bit smaller than this one, even though this one is so much taller. For number 3 here, I have 1/3 times pi times 2, which is the radius, squared, times the height, which is 7. So 1/3 times pi times 4 times 7. And then 1/3 times the 28 times pi. So 28 divided by 3, which is 9.3, and it's repeating pi, and that's still centimeters squared. So if I'm looking at which one is the biggest, has the most volume, this one is just a tiny bit bigger than that one. It's 1/3 of a centimeter cubed, 1/3 of a centimeter cubed bigger. And then number 1, and then the smallest one was number 2. For our last example down here, we have, you are making some bug repellent candles for an outdoor barbecue. I apologize, there's one more after this. What is the volume of wax needed for one of the candles? So we see it's a cone. So we know we need 1/3 of our cylinder volume. So 1/3 of our cylinder volume, that's a 5 squared times 6. And then 1/3 times 150, that commutative property there. And our volume is 50 pi. Now, if they don't tell me to use simply pi, they want me to substitute in 3.14. That means I'm going to take my answer here, and instead of pi, I'm going to substitute in 3.14. And this means that they need us to get a number that we can actually use. And our answer is going to be 157, and that is in inches cubed. On the back, this one's actually our last example. We have the shaved ice vendor wants a new cone to hold this much. Shaved ice being snow cones. When filled to the brim, to the nearest 1/10 of a centimeter, what should the radius of the cone be? So they want just the cone to hold. I know normally snow cones have a big top to them. We're not there yet. So we're just going to flatten ours off. We know that to find the volume, we do 1/3 times pi times the radius squared times the height. They're giving us the volume, so we're going to substitute that in for the volume. That means we must be looking for something else. And they have not told us, but because we want it to the nearest 1/10 of a centimeter, we are going to go ahead for pi and substitute in 3.14. And our height is 9, but they did not tell us what our radius squared is. They didn't tell us what our radius is, so I don't know what that is. So I'm going to put that radius squared at the end, because that helps me remember that I can take all these numbers and I can multiply them together, and that'll give me the coefficient for my variable. So when I multiply these two, and then I end up dividing by 3 or multiplying by 1/3, however you want to think about it, I get 9.42 as the coefficient of my variable, which is my radius squared. I'm then going to divide by that coefficient, and I get r squared is equal to approximately 15.92. I'm going to round that. And so that's what those little squigglies mean. Now I need to do, this is squared, I want it unsquared, so I'm going to use the square root. So the square root of that is approximately 3.99. And you could even, like, it's really rounding itself up, so you could say 3.99, or that's really close to 4, so you could also go with 4. That means it would have a 4 centimeter radius. The partner practice for this is on Schoology, and you want to complete this in your math notebook. Now you also have some space down here at the bottom that you could use, but your math notebook, because you're probably going to want some more space, and then you want to hold on to that information.